In this session, I will talk about the interactive work with Julia. So Julia is already an interactive language, which means that if you already loaded the Julia modules on the terminal, then you can start working with Julia interactively already on the login node. However, notice that the login nodes are shared by several users, and that's why you shouldn't run anything heavy on the login node. And if you want to get to the production data, then you need to submit the job to the batch queue, either by using a batch script, as it was mentioned previously, or by using some more interactive workflow, as I will mention now. So in the different centers, there are several options to deal with the interactive sessions. And here in this table, we show you some of the possibilities. So depending on the cluster, the command that you can use to get an interactive session can be different. For instance, at HPC2N, we use salloc on the terminal, but on other centers, they use interactive. For instance, at UPPMAX and at NSC. And in some other centers, like LUNARC, they have a special launcher that is called GFX launcher. So I will not cover this in this session. I will cover just the HPC2N salloc command. So how does it work? So on the terminal from Kebnekaise, we can start the salloc command with some number of tasks, and we specify the time and also the project name. So in particular, for the present course, we have already our project, which is right above here. For Kebnekaise is this one. So I will start a session with salloc, and then I will request some number of tasks, and then submit a program. So this is how it works in practice. So we specify the project name, the time that I want to get allocated on the interactive nodes, and 30 minutes, it's too much. I will ask for 10 minutes. Then, as you can see here, uh, some time, this time has been allocated on a computing node. In this case, is the node BCN and this number, right? And this means that I can use the compute node that I reserve, yes, to run my code interactively. So how can I do that? I can load, for instance, Julia with this version, and also this tool chain here. And then I can run the command srun, and with this a parameter here. So I loaded already Julia, and I can run the srun command, and host name will only give me the name of the host where this task is running, which will be this one. So you can see here that the task of printing the name of the host was performed 4 times because I requested 4 tasks. Yes. So in that way, you can submit your Julia script by typing srun and the name of the script. And here there is a more realistic example, but also very simple. So this is for getting the sum of 2 numbers, right? I can copy this script here, and then I can create a file called serial sum.jl. So I did it previously, and this is the content of this file, except for the comments. So it accepts 2 numbers, 2 integer numbers as an input, and returns and prints out the sum of these 2 numbers. So how can I run this program? I can type srun, the name of the Julia executable, and the name of the Julia script. But I also need to pass 2 arguments, right? So imagine that you are developing this code here, serial.sum, and you only need to change the value of the parameters to see the behavior of the script. Then this can help you because instead of running Julia on the terminal, which will be doing this, we run this job on the queue by typing srun because I already reserved the resources on salloc. So now I can run this code and notice that it was executed 4 times because I requested 4 tasks here. Yeah. So this is a difference that you need to make in your batch script and in the allocation with this alloc, that here is the number of tasks and -c is the number of cores that you request. So here there is an example for running Julia a job with 4 workers. Yes, and so now if you're done with your salloc allocation that you did it here, so you can stop the allocation by typing exit on the terminal, and this will relinquish the allocation. So otherwise, your job will stay on the queue. So salloc is one way to make your job more interactive, especially if you are in the phase of developing the code. But we also have another way to get interactive jobs at HPC2N by using Jupyter notebooks. And the situation that they will describe right now, yes, involves some initialization step. So we are in the way of making a portal called Open on Demand that can reduce considerably the efforts in this initialization step. So the Open on Demand platform would be available most likely in the following months. But the initialization step that I will perform now is for the current settings that we have now with the ThinLink client, as you can see here. So how does it work? First, you need to install a Julia package called iJulia, and you follow these steps. First, we load a Jupyter Lab module together with the tool chains, in this case GCC core. Also, we need to load the Julia module, and then we start the Julia session on the terminal. So now we go to the PKJ, the package mode, and then we add the package called iJulia. So it takes some time to install the iPackage Julia, but in my case, it doesn't take time because I installed that previously to reduce the time of the video. And after we did this installation, we can type build iJulia to build the package and to set the environments that are variables that are needed. Notice that in some centers, when you do this initialization, a Firefox session is started, yes, but it doesn't work always, right? So in order to make the Jupyter notebook always available, we can do instead the following step. Here it is. So first of all, we exit this Julia session. We have built already a Julia and initialize that. So we create a batch job. In this case, it's called job Jupyter.sh. So I create that with my editor. And I pasted the content on this file. So this is the project name, the number of tasks, the time that is needed. And here, this is the purging line that is recommended at HPC2N, but not on some of the centers, for instance, at PDC. And here there is the module for Julia together with the tool chain. And also this is the module of Julia itself. And this is the line to start a Jupyter lab and some options to get the host name. So, okay, once I have this file, I submit it to the queue. And this retrieves a job ID. So then I can explore the content of this output file from this specific job. And now, when the simulation starts, I search for a line that is called HTTP together with the host, the computing node, and also the token. So I copy this line here. Then I go to the menu on Kebnekaise. And here I go to the browser. Then I paste the line. And you can see here that a Jupyter notebook it has started on the the browser, yes, but it is not running on the login node, but instead of a reserved compute node with Slurm. So this is not important for the current session. This is another plugin that I installed previously that is called Dask. And what we can do now is to create our notebook or to open an existing notebook that we had maybe previously. So I will open this one. And I took this example from the Julia documentation, right? So in order to run this example, you would need to install the plots package. Yes. And notice here that Julia already suggests a kernel that is in the present case 1.8.5, which is the one that we built with iJulia. So now I can start this Jupyter notebook with Julia code, and we can run the job. So you can see here that the job ran, right? And now imagine that you are done with this notebook or the task that you wanted to run with the Jupyter Lab. So what you can do now is uh, close this web browser here, but it doesn't stop your job from running because it is still on the Slurm queue. In order to stop the job, so you need to explicitly cancel the job by using the job ID that you obtain where you submit the job with Dispatch. So here explicitly, I cancel the job and then I am done with the Jupyter Lab. So otherwise, as I mentioned, it will be running on the queue. So this is an exercise that you can try. You can try to run scripts from an interactive session, either with the salloc, or if you have interactive in your cluster, you can use that. So we have seen in this lecture how to start an interactive session, and this part was for HPC2N. So we follow the procedure as usual, but you are loading the Julia module and the possible prerequisites. But in addition to this, we also uh, saw how to run Julia with a Jupyter notebook. Thank you.